The first session of the 2021 Ohio Beef Cattle Management School was hosted via Zoom by the Ohio State University Extension Beef Team on January 18th. During that first session, the focus was on making quality hay for beef cattle with an emphasis on soil fertility and seed species selection. In this excerpt from that evening's presentation, Ohio State University Extension educator Jason Hartschuh discusses the importance of one of the most misunderstood factors involved in maintaining high-yielding forage stands, that is proper soil pH. Listen in as Jason discusses the importance of soil pH and the factors surrounding it.
So when we're looking at soil fertility and forage production, what we have to find is what's that limiting factor. So yield is going to be limited by the element that's in the shortest supply in relationship to the plant's needs, and making sure that we shore up that leak so that we can grow the highest yields possible. The first place we like to start is making sure we have the correct soil pH. Soil pH, is really important that we correct that before we do the seeding. Before that drill goes out or before we go out and try to frost seed a crop, we need to make sure we have pH corrected. Lime takes a little bit of time to react in our soils. We really, on an alfalfa stand, would like 6 to 12 months, ideally 12 months, depending how much lime you apply for that lime to react within the soil and start to move down through the soil profile. Because we really need that reaction down in the rooting zone, not just in the top inch or so. We need it to move on down into that entire 8-inch profile, which takes time. So we need to make sure we look at pH and correct it before the seeding year. So where are the different ranges we need for pH? And what's going on in the soils? So here at this 6.3, where we have grasses, we see we have decent amount of fungi activity, bacteria, nitrates, potassium. Calcium is not quite as readily available. If you're growing a corn crop, that's up about 6.5, and alfalfa, you're looking at about 6.8. You see that fungi and bacteria may be just a little bit more active up there at that 6.8. Sulfur, actually, we're starting to see its decreased availability up at alfalfa versus down at that 6.3 for grasses. But some of these other micronutrients, molybdenum, zinc's becoming less available the higher the pH is, copper is less available, and so is boron. But the effects of soil pH on the activity of soil microorganisms, availability, plant nutrients, and their occurrence of the toxic elements is really important, and one of the reasons we have to watch what the pH of our soil is. If we get down here really low, a pH of about 5, that's where we actually can see increased challenges with aluminum being taken up into crops and actually having aluminum toxicity in forage. We can also get some magnesium toxicities in those really low pH soils. So one of the challenges with pH is, if we look at these two grasses, it's the exact same grass, just grown at different pH. On your left, pH is 4.3. On the right, pH is 5.6. What is the reason for this difference in growth? It all comes down to rooting ability. If we don't have good root growth, we don't have those roots scavenging for nutrients. They're not pulling in water. We may have a decent stand early in the year when we have plenty of water, but if we go into droughty conditions, that pH of 5.6 with a lot stronger root growth is going to survive that drought and continue to put on forage because it has roots down a foot or better into the soil, where that pH of 4.3 is only maybe rooting in the top couple inches. pH really can affect root growth and ability to spread. And pH throughout that rooting zone matters. This here is a bean. If we look at the pH of 7.2 throughout that entire rooting zone, down 18 inches, we have roots going the entire way down. But over here, where the pH is 7.2 in the topsoil, and we have a change into our subsoil of a pH of 4.5, the rooting pretty much stops at that pH change. Some of that we can't control. We have different subsoils depending what our soil's parent material is. We may not have a lot of control over that, but there's some things we can do tillage-wise and liming-wise to at least try to homogenize the top 8 inches and get the correct pH for the crop we're going to grow up in that top rooting zone. So we look at soil pH and its effect on fertilizer efficiency. Nitrogen's about 52% efficient at a pH of 5.5, 70% efficient at a pH of 7, 63 at that pH of 6. So we see a lot more nutrient availability at those more neutral pHs. The same thing you're going to see with phosphorus, about a pH of 5.5, only 15% efficient, 30% efficient at a pH of 7. Same thing over here with potassium, because more efficient the closer to neutral we are. So back to that target pH for different forage crops. Pasture grasses tend to be in that 5.5 to 6 as the pH that most of our pasture grasses prefer. Small grains and ryegrass prefers a little bit low pH too of about 6 to 6.3. Clover about 6.5, and then alfalfa 7. So some things to think about when you look at that is if you don't have the ability to get that pH up close to 7 and you're down that 5.5 to 6 range, you're not going to have an advantage of trying to interseed alfalfa. If you need to interseed a legume into pH down around 6 to 6.5, you're going to be much better off, get more growth, more tonnage, and longer survivability out of looking at interseeding with a clover into your grass pastures or grass stands than trying to put alfalfa in. So that soil pH is 6.5 to 7. It's optimum for those nitrogen fixing bacteria, which is what we really need for those legume crops, the clovers and alfalfas, to thrive. If you look at this picture over here on the left, you see no nodules on those plants. They were pulled out of some soils that had a low pH down around 6. And then over here where we have the nodulation, we're in that 6.5 to 7. And we see a lot of nodules, a lot of nitrogen fixing bacteria going on. Yeah, so somebody asked a question here of what are those tillage options to ensure pH uniformity in the top 8 inches? So when we look at that top 8 inches, the first thing to do before you go out and do tillage to try to incorporate lime. So lime moves very slowly down through the soil profile, but using tillage that stirs, chisel plow and disc will get you about the top 4 inches. If you really have a pH problem in that top 8 inches, some sort of inversion tillage, unfortunately mowboard plow, and planting that right away so we don't have a lot of erosion is the best way to create a uniform pH throughout that top 8 inches by mixing that lime throughout. Um, One of the challenges there, of course, is if you do have hills, you're going to have erosion challenges. So you need to make sure that you put the lime on, you plant a crop to hold the hills in place as we have that lime reacts with the soil to create the pH change. It's not ideal, but often it's needed if we see huge variations in pH. So some ways you can tell if you have that problem is pull different depths of soil samples. So if you pull a 0 to 4 inch sample and then you pull a 0 to 6 and a 0 to 8, you can get an idea of what the pH is throughout those different samples. Or pull that 8 inch core and split a few of them apart to see once how your pH changes across that depth, and submit some samples to the lab where you did 0 to 2, 2 to 6, and 6 to 8, or something along those lines. Just try to see how that pH is uniformly across the top 8 inches. You can always, if you have soils that allow you to, pull deeper cores. If you're going to plant alfalfa, it doesn't hurt to occasionally pull some 12 or 16-inch samples, mostly to look at pH. You don't really want to look at nitrogen and phosphorus on those depths because we just don't have good recommendations.